probably everybody in this room is here because they've heard the bad story about stony coral tissue loss disease. It's been in the newspapers. If you just Google the word stony coral tissue loss disease and you start looking at the hits from about 2016 till present, there's probably 2,000 press releases, articles, newspaper articles, magazines, government white papers that you can access. You would take weeks to go through it all. That's how much stuff has been put together. However, there was really a lack of science going into a lot of the early work on stony coral tissue loss disease, and I felt part of that imperative was to organize scientists in a common thread. I mean, there's some working groups around the Caribbean that have been doing good things, but I wanted to get papers published on this subject. So I basically am co-editing with Sarah, who's here, and a few other editors, a special issue for the Journal of Frontiers in Marine Science. And so far we've published 39 papers, professional peer-reviewed papers on stony coral tissue loss disease. We probably are going to get another 5 or 6 before it ends. So 45 peer-reviewed publications on one topic is really pretty amazing. So that's how I'll start. Again, the question I pose here is stony coral tissue loss disease the coup de grace for Caribbean coral reefs? And hopefully the answer is no. But there's a lot of questions that I'm going to pose towards the end that will leave that maybe as a question for the future. And what are we going to do in the future? So I'm going to give people some like marching orders and some tasks and the things to think about, and shaking up government entities, et cetera, et cetera. So let's go from there. So I throw this slide up because I write here, sometimes you feel like the Grim Reaper. The paper that I sort of made my career on was a paper about white band disease, which was a disease specifically to elkhorn and staghorn corals that spread through the Caribbean in the 1970s, 80s, and early 90s, and removed about 95% of all the elkhorn and staghorn corals from the entire Caribbean. And they used to be the most abundant corals on Caribbean coral reefs, and they were some of the most important framework builders, and they grew at the reef crest, the Cropper palmata, so they were important for storm resistance, et cetera, et cetera. And we lost over 95% of these corals in a couple decades. And then all of a sudden, along comes stony coral tissue loss disease, and I was working on a project, and I'll talk about that, and we just happened to be there, and we happened to be at the place where the disease started, so we were the first to identify and publish on it, as Gretchen had mentioned. So now, like, the second most famous thing I'm known for is another coral disease that's wiping out Caribbean coral reefs. So people don't want me to come to their reefs, basically, is the answer to that one. But I talk about science and serendipity, and it's being in the right place at the right time. Other people will tell you it's basically having good training and being a good observer. And I would hope that the people that have worked with me in the field have good field skills that have learned from other people, including myself. They knew what they were looking for, and my team really was the team that stumbled upon this disease. And we'll talk a little bit about how they did that. But how this happened was, back in 2013 to 2015, they were going to deepen the access channel, the approach to the port of Miami. So if you look at this map, this is Virginia Key, that's Fisher Island, and that's Miami Beach, and this is South Beach, world-renowned South Beach. And this cut right in here is called Government Cut. And Government Cut goes into the city of Miami, and there's a turning basin, and there's a place where the cruise ships dock in there. And then on the other side of the channel, there's a place where container ships come in and take off all these amazing amounts of cargo that comes into South Florida every day. But the idea of the project was to deepen this channel, this approach channel, which was originally dredged in the early 1900s, so over 100 years ago. And before 2013, it was at 42 feet. And the idea was to make it to 50 feet within the same footprint. And it was rock, it was limestone rock, similar to what we have here in Grand Cayman. But the idea was to deepen it so we could accept, or the port could accept, post-Panamax vessels. So they deepened the Panama Canal, which then allowed these container ships to be built bigger and bigger and bigger, which then had deeper and deeper drafts and couldn't get into ports, but they could carry much more cargo and they were much more efficient. So the whole idea was to deepen all these ports throughout the Caribbean and the east coast of the US. And the Port of Miami was the first port in the US to be deepened to post-Panamax class vessels. That's kind of the history there. My company was tasked with monitoring the reef during the dredging to see if there was any negative impact of the dredging on the corals surrounding the approach to the port. And these boxes were these areas where we had biological and ecological transects set up, and we were out there 7 days a week for the entire project. And at the same time, we had sites both north and south, far field control sites that were away from the dredging operation, so we could compare the two to see if what was happening down here or up there was the same thing that was happening at the dredge site or vice versa. And another thing that I think is important to point out here, and you'll understand why in a little bit, that big square right there is the Virginia Key Miami-Dade, Central Miami-Dade wastewater treatment plant. And that takes all the sewage from Miami and treats it at that facility, and then they pump it in a pipe. That's the outfall pipe right there, and they pump it a mile offshore. And they dump it straight out into the Atlantic Ocean, tertiarily treated wastewater. Still has lots of bacteria, lots of nutrients. It's not reuse water. It's not potable. It's treated wastewater. That's 150 million gallons a day is the amount. Okay, think about that. Now think about the population of Miami also, right? So that was what we were faced with. So it wasn't just the port dredging project, we had all these other things going on around us. So these are the numbers of dives that my team did during the project. And you can see at the end of the project, we had 15 divers diving 7 days a week. They would be doing 5 dives a day, have 4 people on a boat, 2 boats. So in any given day, we were 100, this crazy number of dives. So the total number of dives at the end of this 2-year period, 10,865 dives, and well over 1,000 snorkels on seagrass areas that we were monitoring as well. So if anybody knew what was going on out on the reef, it was the staff that we had out there. There was one gentleman, I was telling Tim Austin from the Department of the Environment this morning, about this guy who just during the project did 2,250 dives himself on this one project. And he was actually the guy who found the disease, so we blame it on him. But this kind of gives you some idea of what we were doing, and this is what we were tasked to do. So we tagged a bunch of corals, we did a lot of transects, and every time the dredge was within 750 meters of one of those boxes on that map, we were required to monitor it that week. So over the 80-week duration of the project, each one of those sites was monitored no less than 40 times, and many of them 50 times. And we would do in-situ, the way we would Diver would lay out a transect at a permanent station that we had in those boxes. Person would come behind the person who laid out the transect tape, and they would video down the line. So we'd have a permanent record. And then once that video was in the lab, then we'd actually have biologists in our offices basically analyzing and doing a biological assessment of those videos. At the same time, we had a diver following the person with the camera who would make in situ observations of what they were seeing with their eyes in terms of stress. Were they seeing corals that were being bleached, or were they seeing sediment build up on corals, or whatever the situation might be? So they were monitoring the in situ thing. Then we had another person come behind, and on each one of those transect lines, there were at least 10 tagged corals, permanently marked with plastic tags underwater, numbered, and one person would basically make an observation of that specific coral and take pictures, still pictures of each one of those from all different angles. And this is what was happening every single day. And the end story is these were a lot of very bad years for corals in South Florida, and it wasn't just due to the dredging project. There were elevated sea surface temperatures, especially in 2014 and 2015, which were mass coral bleaching events throughout the Caribbean, but very bad in Florida. We had white band disease hotspots in Acropolis cervicornis in the summer of 2014, which Sarah and I actually published on. There were other diseases that were identified throughout the Caribbean. And then obviously the Stony coral loss disease was first noted in 2014. Other maladies going on. The carnage continues to this day. And then the question I pose at the very end is, what will be left at the end? This just goes to show how warm the waters got. And this is, NOAA has a satellite warning system where they basically measure sea surface temperatures, and they compare this to normal sea surface temperatures. And green would be what the normal temperatures are, and if it gets a little warmer, you go to orange, and then if it gets super hot, it turns red. So you can see both this late summer of 2014 and 2015 from a sea surface temperature wise were very, very hot years. And just so you know, this thing that you see here, there's a thing called the loop current that comes around the dry Tortugas and goes into the Gulf of Mexico, makes a loop and comes back around, and then it goes focused, that current gets focused between the Florida Keys and Cuba, and then zips up between the Bahamas and Florida and becomes the Florida current, which also is known as the Gulf Stream. And then that goes past Bermuda and all the way to Europe eventually, okay? So just look at how hot that water is being transferred from the tropics north even. So the impact of these warm water events are quite dramatic. And these are just temperature log data from a lighthouse in South Florida, very close to where the port was. And these are different years, and the blue line across this graph is at 30.5 degrees centigrade. And that is the bleaching threshold for corals in South Florida. So if corals are exposed to temperatures warmer than 30.5 degrees C for any length of time, there's a chance that they will bleach. And the more days, what they call degree heating days, above that temperature, the more likely they are to bleach. And basically what we saw here, 4-degree heating weeks, 8-degree heating weeks of warm temperatures above the bleaching threshold during those summers. So it was quite dramatic, and that's 90-some% of all the corals bleached. And there were scientists from NOAA, specifically Derek Manzello, who wrote a great paper and talked about this recent rapid warming and what it was doing to the reefs. But there's a link between increased elevated temperatures and disease. And if you just think about hospitals, Do they keep hospitals warm or cold? Cold, right? Why do they keep them cold? Because if you keep them warm, they become petri dishes for diseases, specifically bacterial diseases. So what appears to happen over and over and over again is that there's a link, not a direct link, but a link between temperature and disease. And what we often see is the blue line is temperature through time, and the red boxes are the amount of disease. So notice that the warmest, this is data from Israel, by the way, from a gentleman by the name of Yossi Loya, and the temperature here peaks at about 28 degrees C. This is in the Red Sea where he works. And then it gets down to about 20 and a half degrees during their winter, right? In March, February, March. But this is the peak in September, just like we have here, but the peak disease lags behind the temperature. So there's a shift, a lag that we see. And we see this over and over again. And in 2005, there was a mass coral bleaching event Caribbean-wide. And what we saw after that bleaching event ended, all of a sudden there were disease outbreaks everywhere in the Caribbean. And some of them were really bad, especially in the Virgin Islands in 2005, 2006. So this is what we saw in South Florida during that period of time. So we have the temperature in green. There's the bleaching threshold line.
You've just lost your mic.
So what we see is that the peak bleaching occurs September, and the bleaching lags slightly behind the peak temperature, but then the disease, when it started, lagged behind the temperature. So we see this relationship over and over again. Now, coral reefs typically have some level of disease, just like a population. Somebody in the population has a cold. That doesn't necessarily mean that it's an epidemic flu or COVID type situation, right? But people get sick. And so there's a background prevalence of about 2 to 3% of corals on a reef oftentimes are sick. Okay? Well, when corals get sick, and we're talking about diseases, we usually talk about prevalence where it goes up above 5-10%. That's usually a pretty bad outbreak for a coral disease. Well, off of Virginia Key, this is what we started to see. We started to see these corals get this really weird white line of death across it. The brown area here is the healthy tissue, and the disease is actually moving across this colony. This is a colony of elliptical star coral. The genus and species is Dichocenia stokesi, and it's one of the most susceptible species to stony coral tissue loss disease, and it's one of the first to get infected. And the disease moves with such rapidity across these corals that many of these corals died within a week to 2 weeks of infection. It's crazy how fast this disease moved. And where was that located? There. That's where the disease started, at one of our southern control sites. And notice where it is in relationship to the outfall pipe of the wastewater treatment plant. And the outfall is actually discharging over here. And the trade winds are blowing in this direction. So we, to this day though, don't know the origin of the disease. And no one has been able to figure out the disease pathology, the etiology of the disease. Nobody's been able to isolate the pathogen or pathogens, whether it's viral or bacterial. It's a guessing game right now, and it's not for lack of trying, and it's not for lack of people spending money. So ground zero, this is what we were seeing in the field, and this is the gentleman who worked for me, Ryan Fura. These are pictures that he took when he was doing these in-situ observations on September 26, 2014. And you could see that the coral was still mottled from bleaching. This is a colony known as Meandrina meandrites. And this part of the coral has already died. And then there's the area of active disease. And here's the healthy tissue up here. And this is just another species showing that same progression. This is large groove brain coral known as Copophilia natans. So we collected lots and lots of data, not just in the Port of Miami project, but then when the disease started to spread, I got my daughters, who were all divers, and we got out on weekends, and we went out and we tracked and traced the disease, and that's what we did for about 3/4 of the year. So every weekend I was diving with my daughters, tracking this disease, which was a lot of fun, but it was people were telling me that I was on a crusade to prove something about the disease. Well, I was just trying to figure it out because this was an opportunity and a catastrophe that was literally unfolding underwater. When you have a forest fire that is raging out of control, they call it a conflagration. This was a conflagration underwater. That's the best way to put this. You would dive in the water and more than 50, 60, 70% of all the corals that you saw were diseased. And those corals were destined to die once they were diseased. So these are some of the data that we collected from our swims. These are the data collected with my daughters. Certain species, and they happened to be all in the family Meandrinidae, showed the highest susceptibility. They were the earliest infected, and they also suffered the most catastrophic mortality. The flower coral, Eusmelia fastigiata, Meandrina meandrites. This is, by the way, that same coral that was identified as the ground zero coral. The Dichocenia, I showed you that picture earlier. So notice that a lot of these are brain corals also. So the most highly susceptible corals were the brain corals. And when you look at these numbers, 100% with a sample size of 15, 98% loss with a sample size of 293 colonies, 97% loss, 93% loss. So this is a loss, colonies that died while we were watching them. Greater than 60% of those species were lost from those reefs. So these are the data that we had actually from our project controls at the Port of Miami site. And again, 100% mortality of these highly susceptible species. And these are the county-wide surveys that I did with my daughters. So the outbreak overview is that this species-specific disease prevalence was greater than 66% in more than a dozen species. It was absolutely crazy. And when other people have gone out there, and this is a quote from Erin Muller from Mote Marine Lab, she says, after 5 years of continued infection, this is in the Florida Keys, the disease has an estimated 80% mortality rate. Human analogy, the Black Plague. So basically, this has, in the coral realm, basically it's a pathogen that is as transmissible as the Black Death was, with as high a level of mortality. Or if you put it in modern terms, because we don't have Black Plague anymore, or very little of it, basically it's a contagion as contagious as the chicken pox and as lethal as Ebola. And you put them together. That's what we're looking at. Or think about the early days of COVID, right? Before there were vaccines, and it's very similar, okay? So 30 to 60% of the European population died from the Black Plague in the Middle Ages. 30 to 60% of all the corals, or if not more, on Caribbean coral reefs have died in places where the infection has hit. There are some places where it still has not reached. And two of those places are the sister islands here in Cayman. So Little Cayman and Cayman Brac have not yet seen the disease. And I say yet, and I hope that yet is a forever yet, but the likelihood of it eventually reaching is is likely. And the reason I say that is because I was out diving today. The disease reached here during COVID, summer of 2020. And so here we are in 2023, and the disease is still active on the reefs that were infected 3 years ago. So even though the disease ran through, there's still disease present. And the diseased corals, as they're dying and they're lysing their tissue, that tissue is loaded with all these pathogens, and it's going in the water column and floating around. So this is how it spreads, waterborne pathogen. So COVID was an airborne pathogen. This is a waterborne pathogen. So it is, that's another analogy that we could use, is it's like COVID underwater. Very similar scenarios here. So what we have is, we have these Meandrinidae, the Meandrides, Dichocenia stokesi, Dendrogyrus cylindrus, the pillow coral, highest levels of susceptibility, usually 90, 100% mortality. The next level was the other brain corals. They were very high, generally greater than 85% mortality. And then we had this group in the middle here, and these are some of the biggest frame-building corals in the Caribbean, like Orbicella annularis, which is large star corals, and Montassia cavernosa. These had moderate levels of susceptibility and infection rates. And then there are these groups up here that were low to moderate. And it's very interesting that the youngest families in the Caribbean are the ones that had the highest level of disease, and the oldest lineages, the one genetically that could be traced back furthest in time, were the ones that were least susceptible. So maybe time, in terms of millions of years, had a favorable impact because these corals had seen it all and been through it all before at some level, maybe. That's just the hypothesis. Okay, so when we actually started looking at the rate of spread from place to place in Florida, we could actually calculate the rate of spread from the center where it started by Virginia Key near Miami, and we could actually see how fast it moved north and how fast it moved south. And the main current, as I mentioned before, is a northward drifting current of the Gulf Stream. However, the disease actually spread south against the current. Pretty interesting, right? And that's because there are eddies and backspins off of the main current. So it still progressed to the south, but at a slower rate. So the blue line is the rate of spread north, and the red line is the rate of spread south from point of origin. And when we look at a disease progression map of Florida, this is where it started in 14, 15, 16, 17, 18, 19, 20, 21. So from 14 when it started to 2021, the entire Florida reef tract was engulfed. How long did it take stony coral tissue loss disease to circle Grand Cayman? A year and a half, a year? Right? So, Grand Cayman, yes. And then this is a map of where a group called AGRA, the Atlantic Gulf Reef Monitoring Program, has identified reports and confirmed reports of stony coral tissue loss disease, and the purple and red dots are basically either confirmed or presumed to have the disease. So it's only the areas that are in green, so the southern Bahamas, parts of Cuba, the lower Antilles, the ABC Islands, and parts of the Central American coast currently off Panama and Costa Rica. Everywhere else has basically, and the sister islands. Results from other studies in Florida. This is a group that works out of Nova Southeastern University in Fort Lauderdale. They have a bunch of sites up from Miami all the way north of Palm Beach County. And when you look at their data, you basically see meandrites falling off the same rate it did in Miami as the Dicocenia stokesi, and then a lag of Montassia cavernosa at these same sites, which is what we saw. And it's the same thing we're seeing at every site around the Caribbean over and over and over and over again. So this is percent mortality just of those 3 species from 6 different studies that were done in Florida. And notice how consistent the mortality was in the same species throughout all of Southeast Florida. So basically 92 to 100% loss of meandrites, 87 to 100% loss of Dicocenia stokesi, and 38 to 50% loss in cavernosa, which is the large star coral. Interestingly enough, though, the 38% and the 37%, those numbers are based on data from 2016. And the disease has still progressed and is still endemic in those areas. So what we would expect is if we go back to those sites, that those sites are probably more like 40, 50% like the other sites that had been monitored a longer period of time. And like I said, today I was diving at a location where I've been diving in Cayman since 2016, and coral cover at that location in 2016 was about 23%. And today the average coral cover at that site was 6% based on the data I collected today. I mean, I wanted to cry. So these are other places in the Keys, and you basically see the same thing repeated over and over again, the same numbers. I don't want to harp on this too much, but you can see that there's a consistency. And then when the disease moved to Grand Cayman, I got a phone call from Tim, and he said, I've got bad news. We got the disease here. It was found on the north shore of the island, and what should we expect? And I said, well, based upon my research, this is what I'd expect, this is what I do. And every time I would get a phone call telling me what was going on, it was following this like it was a recipe in a book. It was, and Dendrogyrus cylindrus, which is the pillar coral, one of the most beautiful corals in the entire Caribbean. It's fairly rare, it's not common, but it grows to be very large. And this just goes to show you a colony that's about the size of maybe a Volkswagen Beetle is probably the equivalent of size of this colony. And it basically dies from May of, or early 2015 to sometime early in 2016. So think about how old that colony is. That colony is probably hundreds and hundreds of years old, and it dies within 1 year. So these were data that was as of 2017 for Dendrogyrus cylindrus. Remember, the disease is now marching slowly south. You saw that progression map. Well, 99%, 100% loss, 99% loss. Right now, that entire map is red. 99% of all Dendrogyrus cylindrus in the Florida reef tract are dead. 99%. It is nothing short of staggering. Okay. Beautiful, large, mounding, mountainous star coral, Orbicella faviolata. This is a colony off of Fort Lauderdale, Florida. Okay? And there are geologists that actually cored the center of it. And they looked at the rings, just like tree rings, and they looked at the growth rings, and they basically were able to date that colony back to 1694. That one large colony right there. In December 2015, 1 year after being infected, that entire colony was dead. So we lost 300 and some years of coral in 1 year. And this is what we're seeing over and over and over again. This is a giant colony of Copophilia natan in Palancar Reef, which is a famous dive site in Cozumel, Mexico. Same thing. Large brain corals in the Florida Keys. Same thing. And again, like I said, this disease continues to this day on many reefs at an endemic levels. Now the story for Florida, which is personal for me because, again, my team was the first to observe it. We rang the bell, we screamed from the highest treetops, and a lot of people looked at us and said that we were Chicken Little. That it wasn't as bad as we were saying, and how could that be? And we would even like contact and send photographs and PowerPoints to the local environmental media from the local newspapers. Remember, the disease broke out in Florida in the fall of 2014. The first articles to be written on stony coral tissue loss disease was the first week of December in 2017, 3 years after. And all of a sudden, people started saying, oh my God, what's going on? And then all of a sudden, we had a senator who's now retired, Senator Bill Nelson, former astronaut, and he saw these data and he's like, what are we doing? What is the federal government's response? What response? You've closed your eyes for 3 years. So the thing is, when the hit Grand Cayman, the government, the Department of the Environment was ready, waiting, and responded immediately the day it hit. And that did not happen in Florida. And had we had a response, had we had an early response plan for diseases in general on coral reefs, we'd be 3 years ahead of where we are right now, and we would have been there when it started. So the information that we could have collected in the early days might have been something that could potentially lead to a cure or at least slowing it down. Okay, so this is me being a little cynical. This is my history about notifying the agencies in 2014, and then like the first emergency coral disease workshop being held in 2017. And when the articles came out that said the US government is racing to find a cure, and I'm thinking to myself, well, if racing's 3 years, I hope I never get sick. Okay, so why is this disease unprecedented? It has extremely high prevalence, like I pointed out, throughout these species. Extremely high mortality. If you get infected, there's a really good chance you're going to die. So again, it's like the early days of COVID, right? Especially if you had some sort of secondary impact. Long duration of the event, it's 8.5 years and ongoing right now. It's still spreading throughout the Caribbean, and it's still endemic in the places where it has been before. We've had the ecological extirpation of many charismatic stony corals. What is extirpation? An extirpation is a local extinction event. It's basically where those corals, while they're still in the Caribbean, might not be found on Grand Cayman anymore, or may not be found in Florida. And today, when I was diving, there were 3 or 4 species that were not abundant, but were common in 2016, and you could not find one, no matter how hard you looked today. Okay? And the story's way worse in Florida, and it's way worse in Cozumel, and it's way worse in the Virgin Islands. So just think about, you know, this. What I'm telling you is like the worst case scenario, okay? So what can we do? Obviously, there's lots of stressors. There are things we can manage and things that we can't. And what we've learned in studying coral reefs as scientists and as regulators and as policymakers, even at the government level, is we know what's bad for reefs, and we know that these things have to be managed and can be managed. So things like shipping, port development, tourism, fishing, overfishing. And we also have ways of now restoring reefs. We've learned a lot about restoring reefs. So there are ways that we can aid in their recovery and enhancement. But there are other things, sewage vectors, right? Industrial contaminants, land use alteration, runoff from land, all these things bad for corals. We can do something about those. So what we have to do, though, is we have to do something that basically impacts reefs at all levels, not just local sources of management, not just regulating overfishing or regulating sewage or septic tanks. Or those are all important, and it's 2024. You know, we're civilized nations with fairly deep pockets. We shouldn't be dumping our wastewater at 150 million gallons a day into the Atlantic Ocean, right? I don't think anybody would disagree with that. But really, the 10,000-pound elephant in the room is global climate change. And until we get a handle on those increases in temperature, we will continually, year after year after year, stress these corals. So then, once we expose them to some pathogen, they're ripe for getting picked off, right? And I believe that's what we basically saw. Whether we know what the pathogen was, whether it was viral, bacterial, we know that we've stressed the corals out. We also know that from a global standpoint, the last 10 years of Earth's history are the 9 warmest years in history. And guess what? The other warm year was 4 years prior to that. So the last 15 years basically have the 10 warmest years in recorded history, both sea surface temperature and land temperatures. So it's time for us all to speak out, okay? And how do we do that? Well, obviously, you want to impact wastewater, you know what to do. Okay, I don't want to have septic tanks in my backyard anymore. You do something about it, you contact the Department of the Environment. Department of the Environment can't do much about global climate change, can they? I can't see Tim Austin standing up and stopping global warming or stopping a bleaching event, right? But what we can do is we can impact the policymakers at the highest levels of government who go to meetings like the Conference of Parties in Paris and I guess it was Rio this year, and make a difference and get countries to sign onto treaties and hold their greenhouse gas emissions down, et cetera, because that's the only way we're going to turn this around. Because if we don't, everything else that we do is really a rearguard action. It's an ad hoc, post hoc response to the problem. So that's where I'll leave it. So everybody, get your bullhorns out and your pens and paper and do what you need to do. Thank you. And I ran 4 minutes long.
If you have any questions, we can take them. Just please be vocalize very clearly and loudly so we can hear you on the video. Thanks.
Yes.
Yeah, thanks, Bill. I had the pleasure of diving with you today, and thanks to CCMI and Gretchen for bringing it down. Thanks for the exposure to somebody with this amount of experience. A question when I left the boat tonight, and I thought, God, I didn't have a chance to talk. We were running, we were crazy. Do you think that what you saw on the reef we dived today was the last of it? Because there was still some, you know, we had that epic decline. We had the epic decline from 23, I think, to 6%. But SCTLD was still up. The disease was still there. And was it going to just continue to zero? Or were we going to come back in 10 years? What is the ground level zero?
So there are a couple species out there. One is Porites asteroides. Another is Agaricia agricites. These corals reproduce by what they call brooding, which is they internally fertilize their eggs within the body of the coral, and they eject a planulae, basically a larvae that is already an animal, that then settles, and it can settle near and far from the parent colony. And these species will spawn monthly anywhere between 9 and 12 months out of the year. So right now, those corals are not very susceptible to the disease. So what we're seeing is lots of Parietes asteroides and lots of agricites on the reef. The numbers are not great, and they don't live a long time, and they don't make particularly large colonies. But there are more Parietes asteroides on the reef today than there were in 2016. So, and certainly relatively, there's a lot more. But, so there are certain species that are going to make it, okay? And the question is, do they provide the same function for fish and for other things that live there as the corals that we lost? We don't know the answer to that yet. The other thing that Tim pointed out is we did see other corals that were still alive, and they saw the disease spread through. So these 1 or 2 of this species and 10 of these that made it through were those disease-resistant colonies that now when they have babies, those colonies will be disease-resistant. And again, the answer is unknown at the present time. And there's a lot of experimentation going on at a lot of universities and a lot of marine labs where they're actually looking at this. And these are some of the things that Gretchen and the folks at CCMI are looking at, okay? So I do think that this is not the end of coral reefs as we know them. They may be different. They may not be as robust and as beautiful as we once knew them to be, but they're still going to be around, and they're still going to be productive ecosystems from a natural resource protection provision, also from a provision of where fish live, right? So they will still provide these wonderful services. And from an ecotourism standpoint, it's really interesting. If you're a scuba diver, you come down from Kansas City, or you come down from Ontario, you know, let's say Toronto, Canada, and you jump on a boat and you go out to the reef and you go down, and you don't know what the reef looked like 10 years ago or 20 years ago. And you see the reef today that's called shifting baseline. But the reef looks pretty nice. There's fish, and there's octocorals, and there's sea whips and sea fans, and it's like, oh, that's a beautiful dive. The dive I had today, the water was gin clear. I saw lots of fish. I did see low coral cover, but I still saw lots of sponges, and I saw lots of octocorals, and I saw lots of other things. So it was still a beautiful dive.
Where exactly were you? On the West Bay? Or?
I was on 7 Mile Beach, but the northern portion of, right?
Beach or Northwest Point?
So knife just south of the Kitty. There's a couple of corals.
Sure.
We were shallow.
And that was a place where you had your history with it before and looking at it. And you would say that's coverage is just impacted probably up and down West Bay all the way to
we had this conversation on the
We had this exact conversation.
Yeah, so was this typical? And Justin, who's been diving every SCTLD site around the island, we confirmed that was pretty what's happening around the island. It was very, very...
Which didn't make me feel better, by the way.
Did depth matter? Depth matter in terms of the coverage of the corals that you would expect, or is this temperature related that you know at the high level that you're measuring at the top? You can go down 50 or 75 feet or something like that.
The depths that we were today were between 35 and 55 feet.
We got it 55.
55 feet.
We stayed shallow.
But also, just so you know, back in Florida, the sweet spot for the disease was between 20 and 50 feet.
Yeah, okay.
And it appears that that's what I've heard from people here. Now, deeper.
We've seen that with bleaching, with disease, everything seems to take place.
And shallower, there may be, because of higher wave agitation and more water motion, that they may be able to be a little bit more resistant there as well. I want to tell you something. The best, most luxuriant coral, and it's not a reef, coral cover that we have in Florida today is under the cruise ship pier in Key West Harbor. And The cruise ship pier is basically a vertical wall,
Yeah.
and it's 45 feet at the base of the wall, and that's been a pier, a working pier, that the Navy started using pre-World War I, used it through the First World War, used it as a submarine base through the Second World War, and then they started bringing cruise ships in there in the late 70s, early 80s. And right now, coral cover on that wall is about 70%. Every susceptible species, not one speck of disease, with colonies that are this big. But they're growing in this really bizarre place, and the tide twice a day rips through there at more than a knot, per 1 meter per second current velocities. Just amazing place. And the pictures that I took there this year, if I show them to you, you go, I want to dive there. But of course, it's like the most dangerous place to dive. And it's also no place you'd really want to dive, but it still has a lot of beautiful coral. And it's maybe these corals that are living in these really bizarre environments that have been impacted by pollution and all these other things that are, I hate to use the word uber corals, but or super coral, but they may be these resistant species that may be the brood stock which we can then use in nurseries to replant and refurbish our reefs. Because the lessons that we're learning from reef restoration right now and how we can outplant corals went from being like tens of corals 2 decades ago to hundreds of corals a decade ago to now being tens of thousands of corals. Plus there's other things that are being done as well. Learning how to sexually propagate these things in the lab and all sorts of. So don't, write off restoration as being an important factor in this whole recovery aspect.